Hi guys, so we're going to use this video to kind of talk about 7.1 and kind of the general concept, and we'll talk about kind of where the calculator can help you out here. So this is going to apply to 7.1. 7.1 is on confidence intervals. So let's just kind of look at an example so we can talk about what this idea is, and then I'll show you how to use your calculator. I'm going to say, let's say we're interested in estimating what proportion of U.S. college students have tattoos. Okay, so a proportion means what part of the college students have tattoos. Okay, so a proportion is going to be a decimal between 0 and 1, right? If the decimal is 0.5, that would tell us that half of the college students have tattoos, right? That's a proportion. It's not possible for us to survey every single U.S. college student. Like, we can't do it. So instead, we're going to use a sample and use that sample to make an estimate. Okay, using sample data to estimate things about the population. In this case, our population is the U.S. college students, right? That's our population. So in our sample, it says we randomly selected 100 U.S. college students, that's N, and 37 of them had tattoos, that's going to be X. Okay, how many successes we had, how many actually had tattoos. So there's one term at the beginning of this section called a point estimate. Okay, a point estimate. If I wanted to guess what proportion of U.S. college students had tattoos, and I was only allowed to guess one number based on this sample, I would say, okay, 37 out of 100 had tattoos. So that's 0.37. That would be my one guess. If I was only allowed to guess one number, this is the number I would guess based on my sample. This number is called P hat. It's the sample proportion. Okay, so imagine you're playing a Price is Right game and you were only allowed to guess one number. That would be the best number for you to guess. We would call it the best point estimate. Okay, so then a confidence interval estimate is different. What it does is it's guessing a range of numbers instead of just a single number. So, thinking about the Price is Right game again, have you ever seen the game where you're guessing the price of the car and really it's kind of giving you a range of prices and you have to stop the range when you think it has the price of the car in that range? That's what a confidence interval is. It's guessing a range and we think the correct proportion is in that range somewhere. So the way the range is going to work, let's go ahead and get out the calculator. We'll do it in the calculator first. So in your calculator, you're going to go to Stat, okay? Then you're going to go over to Tests. And there's a whole lot here that we don't really need yet. The one that we need down here, one proportion z interval. Okay, one prop z int. We're doing one proportion. We're using z-scores. That's what the calculator is going to be using, is the normal distribution in z-scores. And we're doing an interval. Okay, so not a test, but we're doing an interval. We'll use the test one in chapter 8. And it asks us for different things. So X is the number of successes in our sample. N was our sample size. And then C level is the confidence level. So I just made up this problem and I forgot to put in a confidence level. But let's say we were going to do 90% confident. Okay, 90% confident means I would put 0.90, right? It's the problem's going to tell you. I just forgot to write it down. So the problem will tell you whatever percent confidence they want you to use. And you hit calculate. And this is our interval. Okay, this is our interval here. So I'm going to round this. It's going from 0.29 up to, I'm going to round it to 0.45. I think a lot of times they actually have you round to 3 decimals, but I'm being a little lazy here. We're going to use 2. So this is saying we are 90% confident that this interval from 0.29 to 0.45 does contain the true proportion of college students that have tattoos. Sorry, my dogs are making a lot of noise. So obviously, if our sample had 37% had tattoos, the chances that that's exactly right are pretty slim because we only based it on 100 college students. Guessing an interval of range of values kind of increases our chances of being accurate, right? We know our sample's probably not perfect, so we'll say, we think it's between 0.29 and 0.45 based on this sample where it was at 0.37. This range, if I kind of put it on a number line, okay, so here's 0 way down here and 1. We're going from 0.29, I'm just estimating, we'll say that's here, up to 0.45. So we're saying we think the proportion is somewhere between here and here. And what you'll notice is that 0.37, our sample, is smack in the middle of that. 0.37 is in the middle. So we're literally giving a range kind of surrounding our sample because we don't know if our sample may have been too high or too low. We don't know. So we give a range kind of surrounding that. Okay, so the range is determined based on something called the margin of error. The margin of error is the distance from the middle, which remember the middle is our sample proportion p hat. The margin of error is the distance from p hat to each end of our interval. Okay, so the margin of error, E, is this distance. So if you take p hat and you add the margin of error, you should get 0.45. And if you take p hat and you subtract the margin of error, you should get 0.29. So the margin of error we can find by taking that upper end of our interval plus the lower end of our interval dividing by 2. No, I'm sorry, I did that wrong. That gives you, that was my bad, that gives you p hat. E is subtracting. My bad. Okay, upper minus lower divided by 2. So in this case, for E, if I do 0.45 minus 0.29 and divide by 2, now I am rounding, so this is actually going to be a little less accurate because I rounded To do this more accurately, you're going to type all the values, right? You're going to use all the decimal places. But I'm in a hurry, so I'm rounding. So we're getting a margin of error of 0.08. Okay, so if I take 0.37 and I add 0.08, I get 0.45. If I take 0.37 and I subtract 0.08, I get 0.29. So that margin of error is kind of like the size of the range that we're guessing. So confidence intervals can be written in different formats. So we already saw this format. This is called interval notation. You'll also see it written using inequalities. Like this, right? The lower limit and then the upper limit. This is saying basically we're estimating that P, the proportion, is between 0.29 and 0.45. And then the third way is writing it as our sample, 0.37 plus or minus our margin of error. So this is also stating the same interval. It's saying we estimate that our sample, or that our proportion of college students with tattoos is 0.37, give or take 0.08, right? Like plus or minus this amount of error. So let's say that we wanted to increase our confidence level from 0.90 to 0.95. Let's say we wanted to be 95% confident. I can just go in here and change this to 0.95. And I want you to see what happens. Now that means we're going from 0.28 to 0.46. So our interval goes now from, let me switch colors, 0.28 to 0.46. So notice it got wider, right? Like this interval is wider than what my original interval was because I increased the confidence level. Okay, so when I only wanted to be 90% confident, we had a margin of error of 0.08. When I want to be 95% confident, they widened the interval. That's going to have a larger margin of error. It's probably, I think it should be 0.09. So increasing the confidence level gives wider intervals with a larger margin of error. Okay, so that's pretty much the general gist for confidence intervals. It's basically when you're trying to make an estimate and instead of guessing a single number, you're guessing a range of numbers, saying we think the proportion of college students with tattoos is somewhere between 0.29 and 0.45, saying we don't know for sure, but we think it's in this ballpark. You can do these in the calculator, right, as I showed you. I'm also going to do a video to show you how to do section 7.2 in the calculator, but it's very similar. So that'll be nice. I'll make another video for that. Let me know if you have any questions.